In this video, I'm going to run through a quick example of using the curve centerline command and some additional steps of breaking curves so I can later connect them with rigids. So let's get to it. I started by importing my geometry, which is a mountain bike frame I designed in NX. The first thing I'm going to do is delete the solid here that I referenced as a tire for clearance purposes. Next, I'm going to use the draw erase tool to hide the dropouts and the axle, and this is so I am left with just the frame tubes that I would like to create center lines for. Now I'm going to create my center lines using geometry, curve, centerline. I'm designing a steel hardtail frame, and most steel frames are using 4130, so that is what I will pick for my material. In my selection dialog box, because I've hidden some stuff, I'm only going to use the select visible, and that's going to pick whatever's on the screen. I'm going to click out of this dialog because that's just the auto repeat. So now I have my center lines created. I'm going to go ahead and use the draw erase tool and hide all of my solids. So now I'm left with just the curves of the center lines on screen. And when I expand out my properties, you can see that it assigned each different property to the different center lines. Again, of a mountain bike frame, the different tubes are actually different sizes, different ODs, and different thicknesses. So when I turn on my thickness here, you can see some of the differences. So I noticed that after my centerline command that some of the curves, the endpoints didn't exactly meet up together. So I would get a discontinuous mesh if I meshed it now. So instead of doing this one by one, I'm just going to use coincident points, select all, visible, measure the distance between two of the overlapping points that should be together, and then add some additional tolerancing to try and capture all of them. So after I do that, I can see that now my points are looking good. They're connected now. So I should get one continuous mesh. And when I say continuous, I mean continuous on each of the curves. So again, right now, these curves aren't linked by any means. So I'm actually going to go ahead and put breaks in the curves so that I can connect them with rigids. This is the area where the seat stays and the top tube would be mitered and welded to the seat tube, which is the curve that is somewhat vertical right now. So I want to break the seat tube along the direction of the other tubes as if they continued on intersecting the seat tube. So I'm going to use the curve location break method and select the centerline curve of my seat tube because that's the one I want to break. And then in the methods, I'm going to use intersect curves and select my seat tube and one of the curves from my seat stay, and then it will automatically break the seat tube at those intersecting locations. So now I'm going to repeat this for the seat tube and the top tube, and you'll see my break is put in there. So I'm going to repeat this method on the head tube to put the breaks in where my top tube and down tube would meet it. And then similar to that, I'm going to put some breaks in the centerline curve for the bottom bracket shell from the chain stays. But this time, instead of intersecting, I'm just going to use a location so it's kind of on plane with where the points from the chain stays would be. And I'll put in one breakpoint at the midpoint of the bottom bracket shell so I can connect the down tube and the seat tube there. So now that I'm done breaking all the curves, I'm ready to mesh. And again, when I did the centerline command, all of the curves had a property associated to them. And even when I was in the Meshing Toolbox breaking the curves, everything retains an associated property, so I don't have to go back and reassociate anything. So now I can just use Mesh, Geometry, Curve, select Visible, and just use the meshing attributes that were already assigned. So now when I show element thickness and cross sections, you'll see the tube shapes. So now I'm going to go ahead and connect my mesh using rigid elements, just RBE2s. And this is where it comes into play when I was breaking the curves, because I know that a node will line up on where I broke the curve. So I can go ahead and select the node that was on the break point of my C tube there. And likewise, I can do the same thing for my top tube and C tube and link those. So I'm going to go ahead and skip forward a little bit. I'm not going to bore you to death with creating rigid elements here. So I'm going to create 2 more rigids here, and really I'm just trying to link the seat stay and the chain stay together. So I'm going to put a node at the center of the dropout, and then create a rigid element that's linked from that node to the end node on the seat stay and the chain stay. And this is really just to simplify where I need to put my constraints. And I'm going to skip forward again a little bit, and now I'm going to go ahead and create my constraints on my nodes that would be in the center of my dropout there. So I'm just going to go ahead and create a fixed constraint. And I'm just going to set up a quick modal analysis to make sure everything's connected, run through a couple node shapes. So I hope you guys can see that using the Centerline tool can save some time on modeling. And in my case, it's just a preliminary design. Maybe I want to get some rough stiffness calculations and go back and edit my geometry. So I'm not at a detailed model yet, but this is a start. So thank you guys for watching.